Alright, my dear learners over there, I greet you once again. How are you doing? Let me hope that everything's moving on well and our mathematics it's moving on smoothly. So let me hope that now we've crushed what you are calling difficult. Now we are from difficult to simple, right? Okay, so and I always tell you that put on a smile. So a smile makes you wiser. Now in this lesson, this is our lesson number 32, and we are going to look at what we call probability. We are going to look at what we call probability. Are we there? So we are going to look at what we call probability. Then when you talk of probability, what comes into your minds? Now when you see this word probability, so probably they tell you, will you come tomorrow? You get probably, maybe probably tomorrow. So what do you mean? So here we are looking at a measure of a chance. So we are looking at chances and we are measuring the chances. How many chances did you have to do this? How many chances did you have to go to Mukono? How many chances did you have to come back to school? How many chances do you have, or how many chances do we have for the schools to be opened? So that is what you call probability. Probable. So probably. So we are looking at the measure of chances. So in other words, probability means how likely something is to happen. How likely is it to rain? Is it likely to rain tomorrow or today? Now. So how many chances did we have? So out of those chances we have, how many do we have that it's going to rain, or how many do we have that's not going to rain? So that's what we call probability. So probability, it is just a chance of an event or something to do what? To happen. It is the likelihood of an event or something to do what? To take place. So is it likely? How many chances? How many how many chances do we have for that thing to do what? To measure, to take place. That's why we are saying that probability simply means the measure of chances, and this probability can be written in terms of fractions. Yeah, it can be written in terms of fractions. So when we look at this probability, we are having what we call the sample space. Now what we call the sample space, this is where we are having all the total chances, all the chances we are having. Then out of this sample space, we pick what we are interested in. So we pick what we are interested in. For example, what we are interested in, that is what we call the desired chance, or the desired chances. Are you getting that? What we want, then the sample space, that's going to give us what we call the total chance, the total chances. Therefore, when we are writing the formula for finding the chances, when we are measuring the chances which we have called probability, I can take this one as DC over the TC, or I can take number of DC over number of TC. Now when I say this, do you understand this? Now yes, this one means number of the desired chances out of number of total chances. Therefore, when you are getting probability, we shall be getting probability as number of desired chances over number of total chances. Okay, let us get started. Let us get one example here. Let us get one example here, but let me first increase on the number of my chalkboards so that we get enough of them. So let me hope that you are ready. You are seated there with your pencil, you have your ruler, everything is on set. Alright, so let us get our example 1 here. Now when you are getting this example 1, let us see what are they saying. They're saying that Uncle Tom will visit us. They are saying Uncle Tom will do what? Will visit us next week. Uncle Tom is likely to come next week, full stop. What is the probability? How many chances do we have? What is the probability that he will visit us on a day starting with letter T. On a day starting with letter t. Now this is the question they have given us. Now we need to know our sample space, our desired chances. Now we need to get to know the sample space. What is the sample space? What are we going to choose? Where are we going to choose from? We are now going to choose from the days of the week. We list them. We have a Sunday, then this is a Monday, there is Tuesday, we have Wednesday, Uncle Kuto might come on Thursday, then he can come on Friday, then again on Saturday. Now our sample space, how many spaces we do in our chances in our sample space do we have? So we are having 1, 2, 3, 4, 5 and 6. So we have 6 of them. Now out of this, there is what we call the desired chance. What do we desire? We desire a day that starts on man or with data t, meaning that Uncle Tom might come on Tuesday or he might come on Thursday, because these are the 2 days that are starting with the letter T. Now how many chances are we having? We are having 2 chances. Then let us get our probability. Now measure will be number of the desired chances over number of total chances in our sample space. Therefore desired chances, how many are they? They are 2 out of 7. So out of the 7 chances, we have 2 chances that Uncle Tom will come on the day starting with letter T. Okay, let us get another example here. Now this example is saying if a die, and some of you call it dice. That is wrong. Dice, it is the plural. When it is only once called a die. So if a die is tossed, you know tossing, if a die is tossed once, those people who are good at playing Ludo, no nyenya, that is no you are once. What is the probability? What is the probability? So what is the probability that a number greater than 2, that a number greater than 2, that a number greater than 2 will show up, will show up. So what is that probability? Now we need to know our sample space, right? We need to know our sample, the sample space, where we are going to choose from. So this is what we call a sample space. So those people who don't know the dice, the die, it is that tube always you use when you are playing Ludo. It is just like this here. It has numbers. It has 1, 2, 3, 4. So it has 6 faces. So it has 1, 2, 3, 4, 5, 6. 6. But now these ones are in form of dots. Those are so good at playing Ludo. Kenny, it is this one, a big one. Then you have 2. Then you have 3. Side with 4. Side with 5. Side with 6. So those are 6 faces. Now that is our sample space. Now from the sample space, we need to get what we call the expected outcome. That is what we call the desired chances. Now that sample space, how many chances we have in the sample space? There are 60 chances. Then those are the total chances. Then from the sample space, now from the sample space, what do we need to get? We need to get a number which is greater than, which is bigger than 2, meaning that we need to get, it can either be a 3, a 4, a 5 or a 6. Now in our desired chances, how many chances are we having? 1, 2, 3 and 4. Therefore our probability is going to be number of the desired chances from the sample space out of that number of the chances in the total in that sample space. Then what do we desire? How many chances do we desire? We have 4 chances. Then out of how many chances? Out of 60 chances. Then this probability is not reduced. So at our level, we are not encouraged to reduce, because when you reduce, you are going to lose the sample space, the total chances. Because see this, if it is 4 out of 6 by 2, 2 by 2, 3. Now this means that the chances were, the total chances were 3, which is not right. That's why we are not encouraged to reduce when it comes to probability. Okay, let us get another example here. You know, mathematics is very interesting, but again, some people put on gloomy faces when they are doing it. No, relax, smile. Smiling makes you brighter. Okay, let us get our third example here. They are saying that if a coin is tossed, I think now all of us will know the coin. if a coin is tossed once, what is the probability? What is the probability? What is the probability of a tail showing up? Of a tail showing up. So what is the probability of a tail showing up? Now when you are getting probability, what does this mean? So probability means number of desired chances over total number of total chances. Now when you look at the sample space, the sample space of a coin has two sides. It has the tail side and the head side, meaning that the total sample space, it is 2. Now if we are desired chances, what is the desired chance we want? We are desiring to get a tail, so there is only one tail, so we have a tail, and now that is one chance. So probability, our probability is now going to be number of desired chances out of the total number in the sample space, which is now going to be 1 as the desired chance out of the 2. Let us now get this other question here. Question number 2. I mean example number 4. Number 4, they're saying if a die is tossed once, what is the probability? What is the probability? What is the probability of, now of part A, an even number showing on top? An even number showing on top. Even number showing on top. Now let us first form our sample space. The sample space we said we have, it is a die 1, 2, 3, 4, 5 and 6. So there are 60 chances, total chances. Now let us get the desired chances. What do we desire? We desire to get an even number. So 2 is an even number, 4 and a 6. So we have a 2, 4 and a 6. So our probability is going to be desired chances over total chances. So what are those desired chances? We are having this is 1, 2, 3. So there are 3 desired chances over total chances, as in 1, 2, 3, 4 and 5, then 6. So there are 6 of them. Okay, so let us get another example here. Part B of that. So it's going to be a prime number showing up. So having a prime number, so the chances of this prime number showing up, a prime number showing up here. So from our sample space we said it is 1, a 2, a 3, a 4, 5 and a 6. So what do we desire? We just desire prime numbers. So the first prime number is a 2, then a 3 and a 5. So our probability is going to be the number of those chances we desire out of the total chances from that sample space. So how many? 1, 2, 3. The desired chance is 3 all over the sum, that is 6. Oh, part C here, a composite number. So a composite number to appear, to show on top. So what is a composite number? So these are the numbers that have 2 factors. Let us first get our sample space. 1, a 2, a 3, a 4, 5, 6. Now desired chances, we need to get a composite number. Remember, this 2 is a prime number, a 3 is a prime number, a 5 is a prime number, meaning that this one, it is not taken as a composite number. What we mean by a composite number? A number that has 2 factors. Then we have a 4 and a 6, meaning that we can multiply this number by 1 and it's off to get a 4, but again 2 by 2 we are getting a 4. So that's why 4 is a composite number. Then our probability here, then it's going to be desired chances, the number over the total chances, which is now going to give us chances we desire. There are 2 of them. Then out of the total, that is a 6. Okay, so let us get another example here. This is going to be example number number 5, right? So it is telling us that in a class of 40 pupils, 10 are girls. 10 are girls, right? What is the chance of picking? What is the chance of picking? What is the chance of picking a girl? The chance of picking a girl, sorry. So automatically measure the chance, that is probability, right? So we are getting the desired chances out of the total chances. Then from the total chances, that is the sample space, how many chances are we having? It is a class, and a full class of 40 pupils. This is the total. Then out of those, there are 10 desired chances, there are 10 girls. So our probability is going to end up being 10 out of a 40, and I told you we don't reduce, as I explained earlier. Okay, so let us get another example here. This is going to be example 6. Example 6, let us take this one. A bag contains 5 good oranges, 5 good oranges, right? Then and 8 rotten oranges, and 8 rotten oranges, and 8 rotten oranges. If an orange is picked at random, if an orange is picked at random, here, what is the probability of picking a good one? What is the probability? What is the probability of picking a good one? Okay, so how do we get probability? Measure of chance. So this is number of desired chances over the total chances. Then what is our sample space? So the sample space, we are having a basket or a box, and this basket has oranges. It has oranges, bad ones, oranges, good ones. Then 5 of them, they are good. 5 are good and 8 are rotten. So in the basket, how many oranges do we have? So 8, then that is 10, so we have 13 oranges. So our sample space has 13 chances. So what do we desire? What do we need to get? So we need to get good oranges. And how many are they? They are 5 good oranges. Then this one makes our probability to be as in DC over the TC, which is now 5 oranges that are good out of the 13 ones that total. Alright, so let us get the activity number 1. Number 1, they're saying in a class there are 60 pupils. In a class there are 60 pupils. There are 60 pupils, 30 are boys. 30 are boys. What is the probability of choosing a girl as a class monitor? What is the probability of choosing a girl as a class monitor? Number 2. In a basket, there are 15 good eggs. There are 15 good eggs and 5 rotten eggs. If an egg is to be picked at random, if an egg is to be picked at random, what is the probability? Probability of picking a rotten egg. Number 3. Okay, a school bag contains 6 yellow. A school bag contains 6 yellow pencils and 5 green pencils. Find the probability. Find the probability of picking a yellow pencil at random. A yellow pencil at random. Number 4. A die is this one. So a die is tossed once. What is the probability? What is the probability that a prime number will show up? Number 5. A football team can win, draw, or lose a match. What is the probability that it will win a match? It will win a match. Number 6. Nora will celebrate her birthday. Will celebrate her birthday next week. Right? What is the probability? The probability that she will celebrate it on Sunday. That she will celebrate it on Sunday. Number 7. The faces of a tube are numbered 1 to 6. And numbered 1 to 6. The tube is rolled. Once. What is the probability that a triangular number will show on top? Okay, you've been a good learner. This marks the end of our lesson 32.